Hello everybody, in this video I'm going to give you a short introduction to analytical chemistry, give you an idea of what it is and what you would be doing if you were an analytical chemist. So let's get right into it. So the first thing you might ask yourself is, what is analytical chemistry, or what does it mean to be an analytical chemist? So a couple definitions here. So analytical chemistry is a branch of chemistry that deals with the identification of compounds in mixtures. So for example, if you had an environmental sample, something from industrial wastewater, an analytical chemist might be asked to determine if there are any components within that sample that aren't supposed to be there or are above some regulatory regulation. Okay, and the other thing that an analytical chemist does is to invent new methods or develop methods to determine concentrations of compounds in a sample. All right, so for example, the recent coronavirus, what was done at the very beginning? How do we measure, or how do we know whether or not somebody had been exposed to the virus, or if somebody currently is infected with the virus? At the very beginning, there weren't any methods to do this. So those involved in developing these methods at least had an analytical background and went through the process to develop this method or a new method to determine whether or not somebody is currently infected. So how do we measure quantities of molecules in a particular sample? How do we express that amount in a meaningful way? Okay, both of those are important because first of all, it might be important to know exactly how much of a certain compound is in a sample, and being able to express it in a meaningful way has to do with who you are reporting those numbers to. Are you reporting it to a client in industry or government? Are you reporting it to a general population? How are you going to give the people the information they need in that meaningful way? So why do we care? Well, there are many reasons why we care. Okay, we care for health reasons and medical reasons. Again, the coronavirus is a good example of both health and medical reasons. Okay, so for example, health, another example, how much fat is in the food we eat. And for medical reasons, diagnosing a disease by measuring components inside the body. Okay, that's going to be a very difficult problem to handle because, as you may know, the components within our bodies, or even the blood within our body, is quite complex, containing a number of different proteins at different concentrations, for example. So being able to pick out one of those proteins or one of those components to determine whether or not it's at a maybe too high of a concentration or too low of a concentration, or maybe not even supposed to be there, is a difficult problem to solve. Forensics is another application of analytical chemistry. How do you know if the explosion was an accident or not? Okay, was there any accelerant that was used, or was it just something that happened by accident? In the environment, how do we know that the concentration of CO2 has been increasing over the past 50 years? We've had to be measuring it. We have to know where we started. We have to know where we are now. So again, methods had to be developed in order to take these measurements. Okay, so here's some specific examples. Counterfeit artwork. How do we prove a painting or other artwork is fake? Okay, we have to know something about the history of that artwork as well. So in earlier years, different components were used for different pigments. Okay, so for example, white was different back in the 1800s than it is today. So we can analyze the paint on a painting, for example, and determine whether or not that particular pigment is a historical pigment or if it is something that is more recent. Driving while high is something that something that has been maybe very briefly mentioned in the news a few years back. Okay, so this might be just as bad as driving drunk. We don't know this yet. There is no easy method to test how high somebody is. So how do we know this is dangerous? How do we measure this particular criteria? Doping in sports. So if you were watching the Olympics way back in 2012, Russian athletes were banned from those events due to tests that were 8 years old. Okay, so methods are continuously improving. So 8 years ago from 2012, right? So back in 2006, maybe the methods didn't exist to measure specific compounds, or maybe there were new compounds that needed to be measured that had become considered as steroids or performance-enhancing drugs in the 2012 Olympics. Okay, detection of viruses. We already talked about the coronavirus or SARS-CoV-2. Okay, and another example I'm going to give in a little bit more detail is counterfeit drugs. Okay, so crossing the border all the time from overseas. Okay, are these drugs? How do we know what's real, what isn't? How do we test for unknown substances? Okay, so one thing about drugs is that there is somewhat of a motivation for people to look elsewhere other than the US for their drug needs. And one of those reasons is because of drug prices. And I don't have any particular experience with this since I live in Windsor across the border, but I do know that there are quite large differences between some of the drugs in both countries in terms of price. So somebody might be looking online, determining whether or not, or trying to find out whether or not there's something cheaper, right? And in many cases, they can find something overseas. And one of the issues with what they find overseas is what you can see here. So both of these pills are Viagra. Both of them say they're from Pfizer. They both look the same, but in fact, one of them is a counterfeit drug. So if you are not privy to the information that there might be some fake drugs out there, if you're just thinking, hey, look, this looks the same, it must be the same, it's just made overseas, you might not know that the counterfeit drug is actually different than the Pfizer-produced drug here in the US. Okay, so it's a couple things they have in common between the counterfeit drug and the approved drug, one that's approved by the FDA, the Federal Drug Administration. They look the same, and they have the same effect. The differences are price and safety. So the drug that has been approved by the FDA has gone through years and years and years of testing to make sure that it is safe for use, that all the side effects are known. So if a particular drug passes the safety criteria of the Food and Drug Administration, then it can be approved for use. Whereas something overseas has not gone through all that rigorous testing, or if it has, we don't know about it. So it leaves the question that, is this something safe to use? So let's just step back a little bit and look at what the active ingredient of the real approved drug is. So this is the active ingredient in Viagra. Okay, sildenafil citrate. This is what it looks like, a somewhat large organic molecule with a citrate counterion there on the right. Okay, so this is the approved drug. This is the one that's been tested. This is the one that's been deemed to be safe. Okay, so now what about the counterfeit drug? What do you think the active ingredient in the counterfeit drug is? Well, here's an idea of what it could be. Now I'm just going to let this scroll. There's a whole bunch of compounds there. And just keep in mind, these are the only compounds that have been found. Okay, so there's been testing done to determine that these particular compounds have been present in counterfeit drugs. Okay, and we're still going. Okay, it turns out that there are about 71 known compounds that have the same effect as Viagra. Okay, those were compounds that were determined now several years ago, so there could even be more. So what is the active ingredient of this particular counterfeit drug that one may have purchased from overseas? Is it one of these 71 compounds? Or is it something that hasn't even been identified yet? Right? So the job of an analytical chemist is, number one, identify the problem. So is this a fake drug or a real drug? If it's a real drug, then one can easily test for the active ingredient. Is this active ingredient present? If it is a compound present in one of the counterfeit drugs that is known, we can also test for those. But what if it's something that we haven't tested for before? What if we don't know what's in there? Right? So one of the questions we're being asked as analytical chemists would be, here's a sample. Something is wrong with it. We're not quite sure what the active ingredient is in there. Go find it. Right? So it's like finding a needle in a haystack, but you don't even know that you're looking for a needle. Or what you're looking for might be something that is somewhat or very different from that needle. Okay, so you got to develop a method to identify the counterfeit molecule, and then you have to validate the method. That basically means you have to be sure that the method that you're using to find the active ingredient in this drug is actually working properly. Okay, so it's giving you the right answer at the end, if you want to call it the answer. Okay, so you have to validate. You have to make sure your method is working properly, and there are a number of ways that this can be done that we may get to a little bit later in the course. Okay, so the general steps of an analytical process are on this slide here. So the first step, identify and define the problem. Okay, so once you know what the problem is, figured out what it is, you're asking yourself a question, something that you can test and find an answer to through some experimental procedures. So step 2, design your experimental procedure. Is this something that has to be done right from scratch? Is it something new? Can you use previously used methods to determine what this particular, or if this particular compound is present in your sample? Okay, establish some criteria to validate the method. Okay, so how do you know this is going to be a method that works well? How can you be sure that it is giving you the right results in the end? Okay, so after you've designed the experimental procedure, you're going to conduct your experiment, gather your data, whatever that might look like. It may look like a chromatogram, which would be a graph of a set of peaks on a graph which show you the presence of specific components. Okay, then you analyze your experimental data after that, maybe do some statistics and interpret your results. Now at this point, you're asking yourself some more questions. So one question that you're going to ask yourself is, does the analysis answer my question? Does it solve the problem? Does it give me the answer I'm looking for? Were there problems in the procedure where maybe I got something like a false positive? So the analysis says that this particular compound was there, but it actually wasn't. Or was it giving me, is there a possibility for a false negative? Meaning the analysis says that the compound isn't there, but it actually is. Okay, so there's a whole bunch of checks and balances that have to go, you have to go through here. Okay, and if it is decided that something has to be redone because of some issue that has to be solved, maybe some additional questions that have to be answered, then we go back to step 2. Okay, design another procedure, modify it slightly, run through the data analysis and data gathering again. So from step 2 to step 3, back to step 4. Okay, and we keep going around this feedback loop until we're satisfied that we have come up with the right answer and we can be confident that our analysis has given us what we're looking for. So after we finish step 4, then we go to step 5, propose a solution to the problem. Okay, so is this answer sufficient? Does the answer suggest a new problem, for example? And if it suggests a new problem, then hey, we got to go identify the problem again, ask some more questions, and run through this whole process again. So the next few slides I'm not going to go through. Maybe you might want to read them yourselves, but they basically give you a little bit more of an idea of what it means to be an analytical chemist, some of the processes that you might have to go through, and some of the additional questions that you might have to ask yourself at each of these steps. Now we may get back to this type of thing near the end of the term, if we have some time. So I'm not going to go over it here because this is not something that is really part of this particular chapter, or at least what part of what I want you to know in this particular chapter. Okay, so know this analytical perspective. Take a look at the worksheets. It gives you some information there. And if you can answer those questions, then you should be good. So that's about all I have to say about this topic. I expect that you probably will have some questions. So if you do, you know where to find me. Send me an email or attend one of my Zoom office hour sessions. And those are listed on Canvas if you haven't seen those already. And they're also on the syllabus. So as always, you will see me in the next video.